here. Today is the last day of our, Today is the last day of our 3-day long conference, ICNSBT 2021. At the outset, let me announce today's schedule. We have two keynote speeches to be delivered today by Professor Michael David and Professor Baj Brinu. Along with that, two technical sessions will be held. Finally, the validatory session will be held by the program chair of ICNSBT at 5:15 p.m. So, to start with our first keynote speech, I would like to request Dr. Debasish Chakravorty to be the session chair. Dr. Chakravorty is a scientist at RRSC East National Remote Sensing Center, ISRO. He has more than 30 years of experience, and his present research interests are in AI, machine learning, and deep learning for geospatial data analytics. May I now request Dr. Chakravorty to introduce our speaker?
Thank you, madam. Very good morning to all of you. So I am very much delighted to introduce today's keynote speaker, Dr. Michael W. David, on behalf of ICNSBT 2021. Dr. Michael W. David has been served as a faculty of the National Intelligence University, School of Science and Technology Intelligence since February 2014. He teaches courses on cyber and data science issues. He is focused on cyber, supply chain, and critical infrastructure security issues. Previously, Dr. David worked for the QV Corporations of San Diego and served as Vice President for International Operations in Tokyo, New York City, Singapore, and Brussels. His PhD is from Kyushu University, Japan. Today, Dr. Michael W. David is going to talk on hyper-intelligent supply chain developments and risks. Now the floor is for Dr. Michael W. David. Thank you, sir.
Okay, thank you very much for that kind introduction and for the opportunity to speak to your distinguished audience there in India. It brings back very fond memories of my my own early studies 20 years ago. When I think about, I think it was 21 years ago, maybe December 2000. I made my first trip to Kolkata for IndoCrypt. And at the invitation of Dr. Roy. And ever since then, have been very fortunate to maintain contact. And once again, I appreciate the opportunity to speak with the audience today. So I'll turn my screen, turn my video off here and try and share my screen so we can get going. So does that show all right on the screen there?
Yes. It is all
okay. Right. So I have to make a mandatory announcement to say that the author, me, is responsible for the content, and the views expressed do not reflect the official position of the National Intelligence University, Department of Defense, U.S. intelligence community, or the U.S. government. So these are just my observations and opinions. I'm trying to see if I can. Okay, is that better?
Yes.
Okay, so what I want to talk about today is supply chains. And I've actually been working, I've worked as part of a supply chain, I guess, for over started almost 40 years ago, and started looking at it from an academic and security perspective about 20 years ago. So in trying to put things in perspective, I thought about, okay, so here we are talking to people involved in cryptographic systems, information security, artificial intelligence. What do they directly have to do with supply chains? And so I wanted to start with a little bit of background as to why supply chains are important. And this was much harder to do, I would say, 2-3 years ago. But thanks to major problems and issues over the last 2 or 3 years, supply chains have come to be topics of the daily news. So in one respect, the dismal situation we face in many ways today reflects a lack of proper attention in what I feel by industry and academia and government to the relevance of supply chains in a multi-domain and multi-technology capacity. So I'd like to start off, like I do with a lot of my own students, is to say really supply chains are the core of civilization. And some of the key elements that we have in any supply chain have been constant for thousands of years. So it is not a new issue, it's not a new problem, but it is a problem that has been, as I say, hyper-automated and blown almost out of proportion because of the volume and velocity of information that we face today. So that was getting a little bit ahead of myself. So let's get back to the basics. What does a civilization of any form need? I know the basics are food, water, information. How do those things get distributed? How do they get to the supply chain? Well, initially by foot, then by horse, then by cart, then by ship. And of course, now we have buses and trains and trucks and airplanes and satellites. It's all, but for centuries, in literally thousands of years, it was pretty much limited to these here. And the airplane is barely 120 some years old. And energy, in many ways, we're using the same energy we have for centuries, and what we call renewable energies are still not cost effective enough and efficient enough and reliable enough to solve our needs. But empires rise and fall in many ways based on their ability to create, maintain, and secure their supply chains. So if you think all the way back to Egypt, Persia, Rome, China, the Mughal empires, they were held together by the ability to transport things and to share information along their highways, either roads and seas. And it's still the same today. If you can't move goods, if you can't move information, if you can't move people, economies don't work. And if economies don't work, societies don't work, civilization breaks down, and we have chaos. So that's kind of the basic thing is here. Yeah, why should anyone involved in, as they say, information security and cryptographic systems and artificial intelligence be concerned about supply chains? It's because it is the basics, it is the core of the civilization we live in. And unless that is stable and reliable and secure, our our lives are not safe and secure. Let me go to the next slide. So what are some of the issues that we face in today's generic supply chains? Okay, so the term we tend to use says as a result of globalization, companies may have less control of and insight into their supply chains. That may or may not be true. You know, is it really? I mean, we have been a globe, and we have been global for centuries. It's just that people and information have not been able to move around the globe as fast as it can now. In the 19th century, to get a letter or to get a message from, let's say, London to Calcutta, it had to go by ship. And before the advent of the telegraph, and that would take weeks or even in months for information to be transmitted. And once it was received, you know, in many ways it would be overtaken by events. Same way for products. Products could not be delivered immediately. They had to go by ship from Calcutta to, let's say, Shanghai or back to London or to wherever it is that a destination might be. And the security of the supply chains has always been an issue. In the 18th or 19th century, there may have been a problem of piracy or the weather, and it's still, ironically, we still have problems with pirates of all things, and the traditional pirates at sea, but also the pirates of our digital supply chains, people who conduct nefarious, malicious activities in cyberspace or in information systems, cause insecurity and unreliability and issues with the reliability of supply chains. And an actual adversary who gains access to a critical supply chain may be difficult to detect. Back in the 19th century, the only way to interdict a supply chain may have been for a ship at sea to capture or sink or another ship at sea and claim its cargo. However, today, from the comfort of one's home or basement or office or wherever you might be, you can get access to information on someone else's computer and take that without being caught, without being recognized, without being punished, and cause as I say, cause difficulties to an adversary or to a competitor. But is there a choice? In many ways, to the globalization. Unfortunately, in many key areas, suppliers are limited. Some very simple examples are rare earth elements and semiconductors. Most of the semiconductor fabrication and production is conducted right now in East Asia, between China, Taiwan, Korea, and Japan. And I think we all know that semiconductors are critical parts of the supply chain for our entire information society. And a breakdown in that supply chain, a breakdown in that system can have a major impact on the global economy. So if countries are adversaries, or let's say as corporations or competitors, seek to gain access to and exploit critical phases in the supply chain of their competitors and adversaries. But is this really anything new? Once again, we take one step back. Is this something that's come upon us because we are now in the 21st century and we have instantaneous communications anywhere in the world, anytime? And the answer, of course, is no. These types of strategies, asymmetric strategies to disrupt or destroy an adversary's supply chain, have long been fundamental to actual war fighting. In one sense, because the university I'm at is as I said, it was mentioned in the introduction, it's a national university, and what we are concerned with is national security issues. So we often see this from a different perspective and optic than a commercial entity or from a truly academic entity. But it is no secret, in fact, that blockades and sieges, in particular, have been part of competition and conflict around the world for thousands of years, and that has not changed. It's just the nature of the systems involved, and systems and the volume and velocity of information that's involved is unprecedented at this time, and it can overwhelm, and it tends to overwhelm many other factors that we're facing right now. So when I do this, like I say, for my own students, I try and think of something that relates to maybe the agency they work for example, Homeland Security, or if they come from the Department of Defense, I relate it to some element of history, war, military history in which blockades and sieges happen. So since I'm speaking today to an audience that I presume is predominantly in India, I tried to search on the topic of sieges in India, and what came up, and I was surprised because I had, in all the years that I've been in and out of India, and some of the studies that I've done, I've never heard of this location, Trichinopoly. And apparently that is a British rendition of a location in the Tamil Nadu area. But what struck me as being very interesting is that in a period of from 1741 to 1752, just roughly 10, 11 years, this one location in Tamil Nadu was under siege by various. This is primarily a result of why was it under siege? It was because, as far as I'm not an expert on Indian history, and so bear with me and let me know if I've made mistakes, or if you know something about this and would like to contribute, please do so. But it was competition between the French and the British and their Indian allies on both sides as to who was going to control that area of India. And the conflict was driven, as I say, by existing rivalries amongst the elements, the regimes in that region of Indian origin, of course, the homeland forces, but also the French and British India trading companies who were competing against each other for market share and business opportunities in India itself. So it should come as, and with all the forts that have been built around India and service tourist sites, it's an interesting commentary. So India should be very, very familiar with sieges and the results. And one thing, and another area here is this one in the middle. It said the siege was listed not because of military success, but because one side bribed someone on the other side. You know, normally some form of espionage or criminal activity or treachery has been involved. And when I looked at this, I thought about it as almost a reverse sort type of attack as ransomware. You know, ransomware means you're doing something to someone and making them pay money in order to get their data back, you know, from the ransomware side. And in this side, you know, apparently one of the opponents paid off someone on the defending side and to surrender. And obviously that was something that impacted on his supposed friends on his side. And of course, the paying your ransomware doesn't necessarily help you. Well, it might help you, but it impacts on someone else who's going to be the next victim. So these things are not really totally out of context. And I say one of the biggest issues we face today is ransomware, and trying to deal with that is something that maybe better cybersecurity and information security and cryptographic systems, and of course artificial intelligence can help us deal with that issue. And which leads into, you know, when you look at a siege, you know, what is it? The standard definition is that it is a military blockade of a city or fortress or port with the intent of conquering by attrition or a well-prepared assault. And siege itself comes from an old Latin word, but is a form of constant low-intensity conflict characterized by one party holding strong static defensive positions, maybe. But, you know, what is that today? You know, how does that compare to actually, here we have constant low intensity conflict. We also have constant cyber penetrations and intrusions and disruptions of information networks and systems by nation states, criminals, terrorists, extremist groups, and anyone else who would like to get on the internet and cause problems for friend or foe. And so my question to you and the audience, and I think in your future research is going to be, you know, how does the concept of, you know, sieges and blockades fit with the cyber activities that we face today in today's world? In today's world is information technology driven supply chains, and that's what we're going to look at to a certain extent today in this short presentation. Now, traditionally, when you think of corporate information technology systems and what they're used for, I think back in the 70s, 80s, and 90s, these are many ways tied to robotic process automations. For example, you know, when you think of a factory assembly line, what do you normally see on a screen if someone's showing it visually? You generally will see the robotic welding arms of, let's say, a automobile factory, or nowadays with electronics, you'll see automated assembly facilities for the cutting and dicing and manufacture of semiconductors, who are then assembled and put together at other locations, and bonding occurs and integration into hardware for information and communications technology products. That was pretty much where we were in the 20th century. But in the 21st century, and most notably in the last, I would say, 10 years, there's been further, the big change in automation and information technology over the last 10 years, and for the next 10 years plus, has been by integrated artificial intelligence, machine learning, and process mining of the Internet of Things and the sensor networks associated with the Internet of Things, and natural language processing to create end-to-end automated solutions for not only what would generally be considered a manufacturing process, but an overall global information technology driven supply chain. And for lack of I think the IEEE word that we're trying to use to describe this is hyper automation, in which things are hyper connected to include customers, vendors, manufacturers, logistics, transportation, accounting, risk management, and all the related systems. In other words, anything and everything involved with creating a product to replacing a product. And what does that mean in reality? So how does a hyper intelligent supply chain work? What happens? What does a supply chain process consist of is, I guess, the question we should be asking. It's not just manufacturing, it's not just transportation, it's a combination of things. And government and other entities actually needs multiple contracts, several contracts to make something like an information and ICT network. Where do you start with? Well, you don't just pull a network out of the air. It doesn't just appear. Someone has to work on a design for a network, right? So a government doesn't own any manufacturing capabilities. They used to, and some governments do, in the effect in the form of state-owned enterprises. And that's a whole another compounding factor of this complex situation, is that the players are not necessarily operating on by the same rules and the same environment or the same situations, because what we normally consider to be the mercantile commercial entities that drive the economies are to a certain degree being skewed by the advent of major state-owned enterprises. And that's, I think, is a real outside, a new player in the system. But is it all that new? Think back to the 18th century example of the sieges in India. What was that caused by? Was that really simply the British and French governments? No, it was the British and French India trading companies who were competing with each other to the actual extent of having armed conflict and mercenary, forces in your country, in India, fighting amongst themselves to control the marketplace. And so maybe it's a good example in today's global competitive market, are we seeing a back to the future type situation where we now have countries who own state-owned enterprises competing with truly commercial companies of other states who are trying to deal with protecting their own markets and securing their own economies and so on and so forth. But back to the actual dynamics, after you get a design, what do you need to do? You have to somehow buy something, the hardware, to make it work. And hardware doesn't do much unless you have what? Software. You have to acquire the software to run on the network so it can perform its required functions. And I'm sure those of you who are there in Calcutta know that the Salt Lake Industrial Facility there north of Old Calcutta is the hub of global software development for multiple industries. And I know I spent time there in the past working with firms, not only Indian firms, but Japanese or Korean firms who have or American firms who have their subsidiaries or partners there in Calcutta. And that's where the software comes from. But then, the system has to go somewhere to be used. And that means integration of them into a unified system. And once again, hardware is nice, software is nice, but it doesn't run forever. And I don't think anyone has seen the system or knows of the system that's running on software version 0.0 or software version 1. There's maintenance and sustainability and upgrades that are required to be done in all these systems. And this is what it looks like in kind of a simplistic form. As I said, someone comes up with an idea in a project, and that, of course, is intellectual property. And this is another major issue that we deal with today, is the theft of this intellectual property and the concepts. In the applied research here, this is the core of starting something, a new product or a new capability or a new system. And this requires a great deal of security and protection. And if you don't protect it, you're likely to face severe difficulties in the future. And the United States is finding itself in that predicament right now. And another, these are more traditional elements of the supply chains, where people are actually involved in production and manufacturing, marketing and sales, distribution and storage, these things in the ships, planes, warehousing, sales forces, so on and so forth. But each was in itself part of the supply chain, but in a different manner. Where Salesforce.com helps things here. They don't make any products. They don't but the products they do make are as it says, related to supporting the sales of other people's. And then once that software is out there and the systems and hardware is out there, people have to install it, people have to maintain it and upgrade it. And for those of you who are familiar with some of the issues of upgrades and maintenance, the SolarWinds problem that occurred in the 2019-2020 timeframe was a result of upgrades in designs that, original designs of software systems that were supposed to be essentially securing the networks that they were installed in, but that very software that was supposed to be providing the security was itself penetrated by malware and caused significant losses of information at that time. And what does a generic supply chain look like? This is a chart from an RSA conference a few years back, and it could take quite a bit time to try to develop. Go through this, but I think it's somewhat. It looks out of line, but it's basically what we're dealing with. And they have the little flags here. It just shows a way of how maybe a smartphone would be is produced and designed, maintained, and you'll see the Indian flag here scattered around within the systems, playing critical roles in the software and operating system areas. And as I say, this is the hardware side, as I mentioned, primarily the semiconductor type side, where you see that production is dominated by Taiwan, China, Korea, Japan, basically in those areas. And it's complicated. I guess that's the easiest way to describe it, is that it's a complex problem and it's not going to get any easier. So what can we do about it? What can you do about it? How can you contribute in your research in your particular field from now on in? So ideally, hyperautomation will enhance the development of more efficient, accurate, secure, resilient, and cost-effective processes within the global supply chains. And hopefully the work you do in information security and artificial intelligence will help business intelligence analysts integrate information from monitoring everything from the robotic processes we discussed to intelligent delivery systems and intelligent document processing. And supply chain managers will shift to working with or applying intelligence based on analytics and insights to more accurate predictions and decisions. This is kind of what it would look like, I would say. Hyperautomation is a product of intelligent document processing, analytics, robotics, and the delivery process. And just some comments on where we are in the current state of the marketplace. Ships and planes and ports and harbors are very important, but they all run on, they're all dependent to a certain degree on digital platforms. And what are these? The use and revenues of digital platforms has exploded, according to an Asian Development Bank report this fall. And the most valuable publicly listed companies in the world today are not necessarily manufacturers. They have products, but a lot of their, the fabless and factoryless companies involved, and some are integrated, some are not. But I think it's well known that these companies probably have a great, incredibly large share of the global market face, and are bringing together different market actors to distribute their exchange products and services. However, these digital platforms, these digital technologies do have a dark side. And as we all know, digitalization has increased vulnerability to cybersecurity risks to the global supply chains and related infrastructures, electrical infrastructure, energy infrastructure, water infrastructure, transportation, so on and so forth. And from our perspective, in my university, we look at things like this, and it's of great concern to us. And especially since it's not government against government, it's government against companies. And I think it's not just the US that's suffering, countries globally are suffering in one way, shape, or form. And what can we do? Well, I say the only thing we can really do is we can't go back to the way it was 10, 15, 20 years ago. We have to, I think our only choice is, and our only hope is for some form of artificial intelligence enabled sense making, in which supply chain managers can better access vast amounts of data from deep inside their supply chains, and the complete chain of custody, entire travel routes, and all the information involved related to that supply chain can be accessed, analyzed, and displayed on three-dimensional maps, so that when data is augmented with all this analyzation, it can achieve AI-powered platforms to help our not only our business managers and supply chain managers, but also our government specialists who are concerned with our economies and our national security issues to be able to deal with these issues and problems that we face today. So in one sense, the good news is no end in sight, because that means we're all going to have jobs for sure, if you're involved in one shape, some way with supply chain or cybersecurity for the next 20, 30 years, you're going to be very busy. So I think that's roughly about my 50 minutes of speaking time. So I'll stop broadcasting at you and return the microphone to the chair and be open to questions. Thank you.
Thank you, Dr. David, for your nice presentations. Actually, you have given the example of historical days, how the supply chain used to work. From that, you have came up with the latest technology, how the artificial intelligence, machine learning also being used for the supply chain. So that is, thank you very much for your nice presentations. So I now will request to participants, if they are having any questions, they can put the question in a chat box, as well as also they can ask. So I will request to participants, if they are having any questions, they can put in the chat box. Participants, if they are having any questions, please, they can ask. Also, they can write in the chat box. So, hello, participants.
Sir, I have one question.
Yes, please.
Yeah, actually, sir, is there any possibility of blockchain in supply chain? That means, can we secure the supply chain management using blockchain technology?
Oh, okay. Yeah, I anticipated that one. There's a major lot of major activities going on. IBM has, for the past, I think, at least almost 10 years, been promoting the use of blockchains as a technology to provide the provenance. Provenance in the sense in the supply chain means the ability to connect and track and determine where various activities take place in the supply chain. So blockchain has a highly significant and important role to play. But as you can imagine, the number of transactions and the data mining that would be associated with that was also an issue. And data mining and the energy that it consumes is also getting to be an issue. So it's a complex problem. It's one that needs to be solved. So I would say there's a lot of opportunities to do data science and artificial intelligence related studies and assessments related to how blockchains can be effective in the support of secure, resilient, reliable supply chains. So excellent question. Thank you very much.
Thank you, sir, for your explanation. Thank you.
So we have a question written in our chat box. Should I read it out?
Yeah, I think I see it there. It says, how did supply chain system counter
Yes.
cyber attack by Chinese? Actually, they didn't. That's the problem. The adversaries were successful in getting away with quite a lot of information. And I think the US and Europe and India yourselves are feeling the impact of the ability of those actors to access your own intellectual property and to actually steal your ability to make money by copying those things by those processes. So it's a tough situation, and trying to secure that supply chain and the intellectual property and the designs, like the designs of semiconductor products and systems, is very important, and that's a major area of concern and activity and importance today. And, you know, if you have an answer to how to counter those attacks, I'm sure you'll be sought after very highly by major corporations and institutions.
Any questions? Any more questions from the audience? Audience, if you are having any questions or any doubt or any, please, there is an opportunity to talk, ask. Dr. David is here. So I think there is no further questions.
Yeah.
So Madam.
Yes, sir.
So what you suggest?
I mean, we can again request participants to put up the questions or write in the chat box if you have any.
So,
Okay.
I think
we have satisfied with the deliberation of Dr. David. Yeah.
Yes. That is
Thank you, Dr. David, for your nice presentation, and we are really thankful to you. And
Thank you for the opportunity.
Yeah.
And I do say Once again, we do need a lot of help, so open to future discussion and contact in this area. Any ideas you have or would be welcome.
Yeah.
Once again, thank you, and I wish you success in the rest of your conference there.
Thank you, Dr. David.
Thank you very much, Dr. David. Thank you very much.
Thank you. Good night. Or good night from here, and have a nice day there.
Same to you. Thank you.
Thank you very much, sir. Yes.
So now that
It
means
was
now
almost it was almost midnight to Dr. David, I think.
yeah.
Thank you for your valuable time.
Yes.
All right, I'm signing out now. Thank you.
Well, thank you very much, sir, for your wonderful session. It was really a very interesting one. And I'm sure our participants would hugely benefit from the valuable knowledge that you shared with us. Now, thank you very much to Dr. Debasish Chakravorty as well. Now, we are about to start